Welcome, future educators. In this screencast, we take a look at the perpendicular bisector, which is the newest thing we will learn how to construct using a compass. So we imagine that there is some segment, this segment, and we want to find the perpendicular bisector, which we can use to, oh, that's not good, which we can use to find the midpoint of this segment. So this isn't really a thing. So let's imagine that the name of the segment is AB, and we're looking for the midpoint of the segment, and we're going to do that by finding the perpendicular bisector of the segment. How do we do that? Well, we take our compass and we open up our compass to at least half as far as the distance from A to B. Doesn't matter how far, as long as it's at least as far. And we swing a big arc. And then we come over to the other side and we put the point on B, and we keep the distance the same, and that's important. We keep the distance the same, and we have a big arc. So we have this thing, it looks like a football or a fish or something in the middle of the screen. Well, then where's the perpendicular bisector? Well, the perpendicular bisector is this line that passes through those intersection points. How do we know this? Well, let's consider what we did. This point right here is on this circle a certain distance from A, and it's on this circle a certain distance from B. And so we know that this distance here and this distance here are the same. And we also know that this point down here does the same thing. This distance and this distance, those are the same. Which means that this red quadrilateral is a rhombus. And we know some things about the rhombus. We know that a rhombus is a parallelogram, and so the diagonals cross at a place that is the midpoint of the diagonal. It's the midpoint of each diagonal. So this point has to, this segment here has to be congruent to this segment here. We also know and can prove that a rhombus has diagonals that are perpendicular. And so we do have a right angle here. So this line is the perpendicular bisector of AB. So why do we care? Well, consider the following. Make a triangle, this triangle. And then let's find the perpendicular bisectors of all three sides. This will give us a chance to practice. So you just take any triangle that's on your paper anywhere. You can have side lengths of whatever you like. In fact, maybe we'll put it over here. And we're going to say, okay, we'll do the perpendicular bisector on this side in red, big swoopy, and then big swoopy, and that was poorly planned because you can't tell where the other intersection is, but it's probably like so, right? And then you come over, oh, you don't. Then you come over, maybe we grab and we come over here and we do the same kind of construction on this side. We don't need it to be quite as long. It's got to be more than halfway, but it doesn't have to be obnoxiously more than halfway. And then we come over here and we flip the thing around and we do the same thing over here. And the perpendicular bisector goes through these two intersection points like so. Right, like that. And then the third segment, maybe we make this green. And then the third segment, we got to open it up so it's past halfway. And we make the big swoopy like so. And then the big swoopy like so. And the perpendicular bisector is this line here. That doesn't really go through. That's a terrible. Here, let's do this. That's better. That's better. So now here's the curious thing. Let's make this long enough, and let's make this long enough. In theory, if we did this right, all three of those perpendicular bisectors come together in one place. If we've done this right, they all come together in one place. Why? What is important about that point? I'm so glad you asked, future educator. What's important about this point? Well, what do we know about all the points on this perpendicular bisector? Because this perpendicular bisector came from this segment here. All of the points, here, let's make this red just to make it more obvious what's going on. All the points on this red segment are just as far from this vertex as they are from that vertex. And then all the points on this segment, the blue perpendicular bisector, are just as far from here as they are from there. And then you look at the third perpendicular bisector, and all the points on the green perpendicular bisector are just as far from here as they are from there. So this purple dot is equidistant from this vertex, that vertex. In other words, and maybe I can do this, this distance, this distance, this distance are all the same. What does that mean? That means there's a circle centered here that goes through all three vertices of that triangle. This special purple dot is what we call, and you don't have to know this, but it's fun to think about, the circumcenter. Circum meaning around, center meaning center. This circle is called the circumcircle, and the circumcircle, which is really hard to say, is the circle that passes through all three vertices of a triangle. And it's found by taking a perpendicular bisector, watching where they cross. So now you have seen 4 constructions of a perpendicular bisector, which means you got to know how to do that and how to recognize it when somebody else does that. And you have a reason why somebody might want to do that. Okay, next up, isosceles triangles.